Then, with Faber tractography algorithm, we evaluated the morphology of the orbitofrontal cortex-related white matter tracts. Here you can see the tracts which we were able to trace consistently in at least 40% of the subjects of each group. Blue are the subjects with autism, red are the controls. You can see the white matter bundles of the orbitofrontal cortex. In order to better clarify the anatomical position, the bundles are overimpressed on images taken from an MRI atlas. What we can quite clearly see here is the reduced spatial distribution of white matter in people with autism compared to the controls. Look, for example, here, and you can see how white matter is less represented in subjects with autism compared to the controls. So quantitatively, it seems that there is less white matter. But the difference appears also to be qualitative. Here you see some images of a whole brain voxel-wise analysis of fractional anisotropy maps of the regions we were analyzing. The red spots, the very small red spots you can see here or here or here, represent the areas where patients show a reduced fractional anisotropy compared to the controls. The voxel-wise analysis revealed that the white matter abnormalities were significant, especially in some white matter areas. In which white matter areas? We can choose one of these slices and try to enlarge it. Here you can notice areas of reduced integrity of white matter around the anterior cingulate and on the curves of an uncinate fasciculus. You see the red spots here or here. These images are somehow confirmed by the analysis of the localization of more disrupted white matter in autism. The localization is given by X, Y, Z axis, and here you can find the nearest gray matter area to these disrupted areas. These are areas mainly near the anterior cingulate and close to some parts of the frontal gyrus, somehow confirming our observations by our authors. But one more, according to us, quite intriguing result of this study was the observation that the IQ scores in the autism group correlated positively with the mean fractional anisotropy values of the orbitofrontal networks. It seems, therefore, that subjects with lower IQ present a reduced white matter integrity than those with higher IQ. So apparently, according to these observations, there is a difference in white matter not only between subjects with autism and controls, but there are differences also in relation to different IQs. So, to summarize our observations, the main finding of this study, main findings were alterations of the structural properties and of a spatial distribution of white matter tracts connecting the orbitofrontal cortex to other brain areas, and especially to some specific brain areas. Which one? First of all, we saw alterations in the connections between orbitofrontal cortex and the cingulated gyrus and the anterior cingulate, as you can see here, these parts. These areas are an integral part of the limbic system, which is involved with emotion formation and processing, as we know, aggressive behavior regulation, anticipation of tasks, motivation, modulation of emotional responses, and so on. It should also be added that the anterior cingulate is involved also in executive control, especially when effort is needed to carry out a task, such as in early learning and problem solving. So this was the first aspect. Then We found alterations also in the connections between orbitofrontal cortex and the temporal pole. The temporal poles, especially the left one, but in both poles. Connections between orbitofrontal cortex and temporal pole, which are mediated by the uncinate fasciculus. The temporal lobe, as we know, is involved in auditory perception and is home to the primary auditory cortex. It is also important for the processing of semantics in both speech and vision. The temporal lobe contains the hippocampus and plays a key role in the formation of long-term memory. It should also be reminded, I think that's important, that the uncinate fasciculus is the last white matter tract to mature in the human brain. Interestingly, and I'll go back to some comments made before by Dr. Costanza, interestingly, structural alterations of the uncinate fasciculus have also been found in schizophrenia. Moreover, schizophrenic patients present also reduced fractional anisotropy in the anterior cingulate, a feature observed also in such population. We don't know if these abnormalities might point to wider abnormalities or not, but I think that's in any case an interesting point. Lastly, we found also alterations in the connections between the orbitofrontal and the prefrontal cortex. Prefrontal cortex, as you know, is an area which is involved in complex thought and in emotional expression. Obviously, such a study, as I presented it here, has several limitations, and we have to acknowledge the limitations of such a study. The major limitation is the small number of subjects enrolled, and therefore its limited statistical power. But as shown before, the study of low-functioning autistic subjects poses several technical difficulties. Furthermore, anesthesia might be in itself a confounding factor when comparing anesthetized subjects with non-anesthetized controls. However, it is difficult to exclude such a factor in an MRI study of low-functioning autism. Lastly, it must also be pointed out that DTI, like other similar techniques, is sensitive to magnetic susceptibility and geometric distortion artifacts. So, discussing the results, these limitations have been correctly taken into account. But, and I conclude, notwithstanding these limitations, we think that these results might help to broaden, even though in a preliminary way, our understanding of white matter abnormalities in autism. And particularly, our results point to a relationship between the severity of the intellectual impairment and the extent of white matter alteration. At the end, we should theoretically thank our sponsors, but unfortunately, there are neither private nor public sponsors to thank. The only sincere, that's the situation in Italy today, the only sincere and deep thank you goes to those who participated in the study and their families. Without their determination never to give up, such a study would have never been possible. Thank you so much for your attention.